Assalamualaikum warahmatullahi wabarakatuh. I'm NORHAYATI binti Abdul Rahman. Today I will present my research project on biocatalytic reduction of formaldehyde to methanol, effect of pH on immobilization and reactive membrane performance. First, I will explain the abstract of this study. The alcohol dehydrogenase which catalyze the formaldehyde to methanol and simultaneously oxidize NADH to NAD+ will be immobilized in polyether sulfone membrane at different pH. The experiment was conducted in a depth and stirred filtration cell fitted with biocatalytic membrane, and the objective of this study focused on the effect of different pH on enzyme immobilization in membrane in terms of permeate flux, observed rejection, enzyme loading and falling mechanism, the reaction conversion and also biocatalytic productivity also being evaluated, and the results show that the permeate flux during immobilization for pH 7 and 9 were 10.51 and 15.9 liter per meter cube hour bar respectively. Higher concentration polarization and also falling resistance also occur, cause lower observed rejection during immobilization of pH 7 and 9, and enzyme loading for pH 5 shows the highest loading rate, which is 87% loading rate compared to the other pH. Meanwhile, the conversion rate during the reaction show that the reaction on fault membrane giving almost 100% conversion, and the falling model predicted that irreversible falling occur during immobilization at all pH with standard blocking mechanism. Introduction for my research project is about immobilization. The immobilization is a simple method to protect the enzyme from unfavorable condition. It's also applicable in separation of product to achieve the desired conversion of product. Based on recent article, enzyme immobilization is published related to the enzyme immobilized on the surface of polyacrylonitrile by nitric chemistry to immobilize lactase enzyme. So basically, as we can see, non-covalent technique is not being discussed in enzyme immobilization method in literature. So in this study, adsorption method, which is physical immobilization method, has been used to carry the ADH enzyme on the support layer of PES membrane. Adsorption method is known as the simplest pressure driving to demonstrate the falling on the membrane support. In this method, the enzyme absorbed on the surface of PES membrane by hydrogen bonding, van der Waals forces and hydrophobic interaction. The advantages of this method is to make sure the enzyme activity and substrate specificity, at the same time easy the performance of possibility to reload the membrane with the fresh biocatalytic, and also can reuse the membrane for other applicable production. And then we focus on the effect of the pH, which is the theory of enzyme that dock on the membrane pore with the different pH related with falling by electrostatic and hydrophobic adsorption, and retention by electrostatic repulsion and strict hindrance. And then the problem statement for this study is the immobilization strategy for enzyme reusability and for reactive membrane, and the scope related with permeate flux has been observed during immobilization and also the reaction. on the support layer of polyether sulfone ultrafiltration membrane. EDH is being catalyzed formaldehyde to methanol with simultaneous enzymatic reaction, oxidation of NADH to NAD+. There is cascade catalysis of formaldehyde to methanol. The objective of the study is to observe the effect of different pH on enzyme immobilization in terms of permeate flux, observe rejection, enzyme loading, and also falling mechanism, and the conversion rate and also biocatalytic productivity is also being evaluated, and to determine the falling mechanism based on Hermias model. Next, I will explain the methodology for this study. First, the important method is cleaning membrane using 50% ethanol and also ultra pure water. And then there are two major process in this study, which is enzyme immobilization and also enzymatic reaction. First, for enzyme immobilization, the ADH enzyme is immobilized with 30 ml solution of 0.1 gram per liter enzyme concentration on the support layer of PS membrane with using sandwich mode, whereas the support layer phase feed, and the solution of buffer with different pH 5, 7 and 9 using 2 bar of nitrogen gas. And then the second major method in this study is enzymatic reaction, which is the reaction of 30 ml of substrate mixture contain 134 micromole of formaldehyde with 100 micromole NADH using constant pH 7 solution filled in amicon stirred cell with fold membrane, the fold membrane and the support layer facing the feed. Firstly, place the solution for immobilization and the reaction in amicon stirred cell. After that, collect the permeate flux every 4 ml, and then prepare the sample preparation for UV spectrophotometer analysis to identify the concentration of enzyme after immobilization and also after reaction. And then the absorbent was analyzed by UV vis, and then the concentration of the enzyme is being analyzed. And then after that, we proceed to the analytical method to obtain the permeate flux, observe rejection, enzyme loading, and conversion rate, and also linear regression to identify. I proceed to the result and discussion. First, I will discuss the permeate flux during immobilization. The permeate flux showed the permeate decrease rapidly during immobilization at pH 5 because the highest irreversible falling resistance occur. Decreasing of permeate flux also because of isoelectric point of PES membrane and ADH is around 4.9 to 5, and the membrane become neutral so that the membrane hydrophobic absorption occur and fold the membrane. After that, the observed rejection also used to identify the solute solubility that retain the membrane, which the solute diffuse through the membrane. Based on this result, observed rejection at pH 5 shows highest rejection compared to the other pH. And then I proceed to the permeate flux during enzyme reaction. The permeate flux during reaction on fault membrane give the lowest permeate at pH 5, which is 8.74 liter per meter cube hour bar, because more enzyme is doped on the membrane. Because of the slow permeate flux, we can see the conversion rate show highest conversion at pH 5, where the fault membrane react with formaldehyde and NADH to produce methanol. And then, as you can see, this is the result for enzyme loading during the experiment, and it shows that enzyme loading at pH 5 give the highest loading, which is 87% compared to the other pH. And then this is the linear regression calculation that show the standard blocking and intermediate blocking at all pH due to irreversible falling resistance. So, as a conclusion, we can conclude that membrane fault by pH 5 solution is more recommended, as the enzyme promotes full dispersion of enzyme molecule on the membrane support. More enzyme dope on the membrane surface, as IEP of PES membrane and ADH enzyme are around pH 4.5 to 5. And then the following mechanism dominates the standard and intermediate blocking because of at all pH, because irreversible falling occur during the enzyme immobilization. And then the conversion rate during reaction shows the highest conversion rate at on fault membrane at fault membrane pH 5. And then to be conclude, lower pH is chosen for further study of falling induced enzyme on the membrane support. That's all from me. Thank you.